Hello and good afternoon and welcome. Hey, it might not be afternoon, so let's just go with hello. My name's Darren from Maths Guru, and these are my suggested solutions to the General Maths Written Exam 2 held on Monday, the 30th of October, 2023. Thanks very much for joining me. Hopefully you find these solutions useful. Now, they're my suggested solutions. I have nothing to do with VCAA. I am not endorsed by VCAA, and in fact, I don't think VCAA want anything to do with me, but I just hope. But the chances are I may make one or two mistakes, all right? I am sorry, I am human. And if I do, I'll put an errata in the description below. Or if you're watching on maffsguru.com, then I'll put it there as well. Well, my throat's already sore and we haven't even started. Now, if you can do me the massive favour and subscribe to my YouTube channel, it really does mean the world to me. I got 200 subscribers. What? I mean, like, as I said last time, I phoned my mum up and went, "Mum, I've gone viral." She went, "You got a virus?" I went, "No, Mum, don't worry about it. It's just YouTube." Old joke, but I really like using it. So you've had enough of me talking? Yeah, I thought so too. So let me hit the right button. There we go. General Maths Written Exam 2. This is the first time I've seen it. You guys actually have just about finished it now. It's 3:30, so I think you're almost done. Question number 1. Data was collected to investigate the use of electronic images to automate the sizing of oysters for sale. Where did they get these contexts from? The variables in this study were ID, weight, volume, image size, and size. The data collected for a sample of 15 oysters. I'm going to highlight that because I've got a horrible feeling that's going to come in useful. Is displayed in table 1. Write down the number of categorical variables in table 2. Well, there's an age-old question that we love. Now, obviously, in this situation, categorical variables, generally speaking, can't have a mean or a median. And so in that situation, right, well, let's go through. Weight is definitely numerical, so it's not that. Volume, numerical. Image size, numerical. Size, that was there, is 1. And I think the trick to this question, there's always a trick to these questions, is ID, because although it's got numbers, it doesn't actually stand for anything. Just because that first thing has an ID of 1 doesn't relate to anything. So I'm going to go with 2, I think both ID and size. So write down the number of categorical variables in table 1 is 2. Marvelous. Determine in grams the mean weight of all the oysters in this sample. So I want the mean weight. I tend to highlight them so that I don't, when I'm putting them into my calculator, make a silly mistake. Let's fire up my calculator now. For the ClassPad users out there, I am truly sorry, guys. I don't have a ClassPad license, and on the whole, the functionality is pretty similar. So let's see what we're going to do. We're going to go menu. Oh, no, we're not. We're going to go control, doc, list and spreadsheet, and I'm going to type in there WEIGHT. Says trying to see past his what is this thing called? A microphone. Yes, microphone. Right, so weight 12.9. Now, when I put these datas in, I am always checking every one that I put it in and don't make a silly mistake, because making one silly mistake can generally cost you lots of marks, because there's all sorts of things they can do with these questions. 7, 12.6, 12.5, 10.1, 10.6. 13. See, I nearly made a mistake there. 13, 8.1 and 14.1. Now, there we go. The first thing I check is that I've got 15 data items, right? There's 15 oysters, 15 data items. I'd hate to miss one because, again, so I'm just going to scroll up and just see, do any of these not make sense? 15.5, 9.6, 6.8. 71.4, 11.4. Now, the chances I'm going to use all of these a bit later on. They might ask me to do a scatter plot. We'll wait and see. But there we go. So what I'm going to do now is I'm going to go menu, statistics, stat calculations, 1 variable statistics. Yes, I've said 1 variable. My X list is weight. Click on OK, and there we go. We're going to scroll down, and there we go. Now, obviously, many people make mistakes on these questions because of accuracy. All right, they don't put them to the right number thing. Determining grams, the mean weight of all the oysters in this sample. That's interesting. They didn't give a accuracy for that one there. So I'm just going to just check the front of the paper to make sure it didn't say anything there. Unless otherwise stated, or space provided. Right, okay, well, I'm just going to write whatever my calculator gives me there then. Right, so I'm going to put the whole value of 11.42. So let's actually not do it in highlighter. 11.42. Cool. The median weight of the large oysters. The median weight of the large oysters in the sample. Okay, so now we're going to go back to this again. All right, because he doesn't just want the median. And I think what VCAA think is going to happen is people are going to scroll down on here and just read off the median. But that's not what it wanted. It wants the median of the large oysters. So let's scroll. I'm going to delete this, and I'm just going to highlight my large oysters. So there we go. There's my large. There's my large. Have I got any more? Yep, there's a large. Really need to get my eyesight tested. There's a large, and there's a large. Have we got all the large? Yes, I have. I'm just going to check again the median weight of all the large. So what I'm going to now do is write those out in order. So I have 5.3, 5.3, oh, 5.1, yep, 5.7, and 6.5. Median, one in the middle, fairly obviously there, 5.3. So for this one, I'm going to go for 5.3. Yeah, and again, I always go back and check because I've got the advantage of being able to do that, just to make sure if I colored in all the large oysters, I have indeed. And there we go on the median weight. Ah, you see what I did there? Automatically, silly mistake. All right, and again, I'm doing this live now, and I will probably keep that in. Actually, I won't. Now, it's at this point that I actually made a silly mistake. Why did I make a silly mistake? Because I went for median image size. Yeah, my brain was working, but I want the median, what was it? Sorry, the median weight. So let's put these in order. I've got 12.9. So I'm going to start there with 12.9. I've got a 17.4. I've got a 15.5. What else have we got? A 13.0. And I got a 14.1. So there's a 14.1 in there as well. So as far as I'm concerned, the middle one's going to be 14.1. So let's put 14.1 in there. And again, it's so quick to do the median weight of the large oysters. Right, what's next? When a least squares line is used to model the association between weight and volume, the equation is given by that. Name the response variable. Okay, we like that one. The response variable, nice and easy. It's the one on the left-hand side of the equals. So I'm just going to put volume for there. Okay, now moving on to C part 2. Complete the following sentence by filling in the box provided. The equation predicts that on average each 10-gram increase in the weight of an oyster is associated with. Wow, this is interesting. So I'm just going to delete that for a moment because the trick here is normally they say, for every 1 gram increase in weight, but now they're saying 10 grams of increase in weight. And obviously then we're looking at the gradient and we're wanting to see, well, if this has actually become 10 grams, not 1 gram, and it's 10 times bigger, then we would need to make this 10 times bigger as well, which will give me a wonderful answer of 9.53. A least squares line can also be used to model the association between an oyster's volume and its electronic image size in megapixels. In this model, image size is the explanatory variable, rightio. So I'm going to draw a quick line there. So image size, and what was the other one? Volume. Right, okay, so what have I got to do now? Well, basically, my calculator is no use to me because all that data is gone. So I'm going to clear it all off, and I'm going to start again. And I'm going to do volume, and I'm going to do image. All right, he says, because I can't spell. Let's do image. Right, here we go. So go back to my table. We're going to put in the volume. So we've got 13, 11.7, 17.4, 7.2, 10.1. Sorry about that, my screen just squished off. 15.6, 9.9, 7.5, 12.7, 12.7 again, 10.5, 10.8, 13.1, 8.5, and 14.2. All right, there we go. So if we're just going to check those as I go back up. 14.2, 8.5, 13.1, 10.8, 10.5, 12.7, 12.7, 7.5, 9.9, 15.6, 10.1, 7.2, 17.4, 11.7, and 13. Yes. Now do my image size, 5.1. Cool. I wish I kept those previous ones. Now you're going to talk to me and say, what do you mean your previous ones? And I'm going to say, like a Muppet, yeah, I think I put this data in earlier. I thought, nah, I'm not going to need it. 2.7, 5.55. 3.9, nearly did 5.9, 4.1, 5.3, 3.5, and 5.3. There we go. So there's my data in. What does it want me to do? Least squares regression line where my image size. So I'm going to do control and doc. Let's do a data and statistics. Let's do image along the bottom. And let's do volume up the side. There we go. That looks pretty cool. Pretty animation. From the data in table 1, determine the equation of the least squares line using the template below to write your answer. Round the values to 4 significant figures. I wonder how many people are going to trip up on the 4 significant figures. So, menu, Analyze regression a plus bx, and move it up here so that it doesn't look like it's in the way. Now again, it's not y equals. Again, I wonder how many people put the y in there. It isn't. Your calculator's a dumb piece of machinery. Sorry, calculator. But basically, I've got to make sure that I do what's on the y-axis, which in this case was volume. So I'm going to write volume here equals 0.00. Oh dear me. 0.00. Now to 4 significant figures, that's going to be 2857. 2857 plus 2.571 times my image size, I think it said, wasn't it? Yeah, image size. And there we go. Volume equals 0.002857. Yeah, I'm just going to check my values on that table were actually correct, because that seems very small, but it might well be that VCAA are trying to make things a little bit harder. So let me see, what did I have? 5.1, 4.8, 6.5, 2.9, 3.7, 5.7, 4, 2.7, 5.5, 5, 3.9, 4.1, 5.3, 3.5, and 5.3. Okay, let's go with that then. Yuck, those numbers aren't nice. The number of megapixels needed to construct an accurate electronic image of an oyster is approximately normally distributed. Measurements are made on a recently harvested oyster show that. So I'm just going to hide my calculator for a minute because I need some space. Let's delete that for a moment. All right, 97.5% of the electronic images contain less than 4 megapixels. Oh, again, they're doing this a little bit trickily. So here we go. There we go. All right, so we know that 97.5% of the electronic images contain less than 4.6 megapixels. Right, so that's 50, 84, that's 13.5, so 84 and 13.5, or is it 12.5? Yeah, it's 12.5. No, 13.5, yep, which gives me the 97.5. Right, so we know that if it's less than, we know that that there is going to be 4.6 megapixels. Yep, and then what have we got? The next 84% of the electronic images contain more than 4.3. All right, so 84% contain more than that. So that's 50, 60, 84. So that one is there. So that's 4.3. So there is the space I need. 1, 2, 3 sections. Use the 98, 95, 99.7 rule to determine the megapixel as the mean and the standard deviation. Okay, so I've got values going from 4.3 to 4.6. And that's going over 1, 2, 3 standard deviations. So if I actually bring up my calculator, just to show you guys how I would have done it. Let's go Control, Doc, and add a calculator. So I do 4.6 minus 4.3. 4.3 gives me 0.3. I'm going to divide that by 3 because there's 3 standard deviations. So my standard deviation is 0.1. And basically to then get to my mean, I'm going to add that on, because to get from that 4.3 to my mean, I'm just going to add on 0.1, which is going to give me a mean of 4.4. Now, I hate the fact that I don't have the answers to this. It's beginning to mess with my head. The following data shows the size of a sample of 20 oysters rated to small, medium, or large. Use the table above, or the data above, to complete the following frequency table. Small, the number of small, right? Okay, so we got 1, 2, 3, 4, 5, 6, 7. All right, now again, why do I highlight them? Just makes my life a bit easier to make sure that I haven't missed any. Yeah, so let's change my highlight color for the next one. What have I got? Medium. So I'm looking for medium. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, and there's 10. And then change the color of my highlighter again. Let's go purple for my large. 1, 2, 3. All right, 3. Now, when I add those all together, I get 20. All right, so when I've added that column, I've got 20, and it tells me I should have 20. None of them seem to be colored in incorrectly. So there we go. Use the data above to complete the following frequency table. Ka-ching, 7, 10, 3, and 20. Use the percentages in table 2 to construct a percentage segmented bar chart below. A key has been provided. Now, I'm not sure that the order is going to particularly manage, but it's given you the percentages here. 35, 50, and 15. And the question says it wants a percentage segmented bar chart. Let's actually highlight that in a color that we can all see. Percentage segmented bar chart below. A key has been provided below. Okay, so where are we? Small, medium, and large. So small is going to be 7. Now, use Hey, not 7, sorry, 35. Please, 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 guys, use a ruler. They will be expecting you to use a ruler. So luckily my iPad lets me do that. Right, so that's going to be small. They've given you the key. They obviously want the cross-hatching to be a particular way. So then I'm going to do my cross-hatching in the way that they expect it, yeah? So that's 35. I'm going to put a tick there. 50% are going to be medium. Now, obviously, what I want to try and do there is say, well, okay, what's the height of that? Well, I've already got 35. I'm going to add on another 50, which gives me 85. So I'm now going to go to 85, draw a nice, beautiful horizontal line. Here, my median should have vertical lines. Well, my medium has got vertical lines, and large should be 15%. And again, is this area now 15%? It would appear it is. So I'm going to do my cross-hatching the other way. Oh, look, colouring in, VCD, Studio Arts. How exciting. And there we go. And so that's my percentage segmented bar chart. Percentage, not frequency. Likey, likey, likey. An oyster farmer has 2 farms, A and B. She takes a random sample of oysters from each of the farms and has the oysters classified as small, medium, or large. The number of oysters of each size is displayed in the two-way table below. Calculate the percentage of the total number of oysters graded as large in this investigation. Calculate the percentage of the total number of oysters graded as large. I don't think I like the answer. I don't think I like the wording of that question. Calculate the percentage of the total number of oysters graded as large in this investigation. Okay, so if we look at the total number of oysters that are large, it's 44 and 46. Now, 44 plus 46. I'm doing this offline because I hate making silly mistakes. So it's 90. Okay, so how many oysters are there in total? Well, there's 90 of them are large, so obviously it wants total number of oysters, and the total number of oysters would be if I added those together. So let's bring up my calculator, just so that you guys can see what I'm doing. 210 plus 320 gives me 530. Oh, if I got $1 for every time I did that. 530. And so what I'm now going to do is my percentage would be 90 over 530 times 100. So 90 divided by 530 times 100. Oh, no. 530 times 100 gives me 16.98%. Round the percentage to the nearest whole number. I think that's going to be 17%. Voila. The farmer believes that Farm A has a greater capacity to grow larger oysters than Farm B. Does the information in Table 3 support the farmer's belief? Explain your conclusion by comparing the values of 2 appropriate percentages. Interesting. Right, so in this situation, I'm going to percentage all of these things in my columns, and we'll see what happens there. Hit the wrong button there. So 42. So I'm going to do the 42 out of the 210 first. So 42 divided by 210 gives me 20%. So I'm going to write 20% there. 124 divided by 210 gives me 59%. And then 44 divided by 210 gives me 21%. All right, so there we go. There are my percentages. Now I'm going to do the same for this column. So I'm going to do 114 times 320. 114 divided by 320 gives me 36%. 160 divided by 320. Is that right? 320. Gives me 50%. And what am I trying to do now? The other one, 46 divided by 320, gives me 14%. Right, now here's good. The farmer believes that Farm A has a greater capacity to grow larger oysters than Farm B. All right? A greater capacity to grow larger oysters than Farm B. Does the information able to support the farmer's belief? Explain your conclusion comparing the value of 2 appropriate percentages. All right, well, if I look at my large oysters, I'm going to say, does the information in Table 3 support the contention? Yes, it does. Yes. And full stop. And then what I'm going to do is I'm going to look at the percentage of medium and large. All right, so it says, explain your conclusion by comparing the value of 2 appropriate percentages. All right, so again, I would imagine, yes, looking at large oysters, comma, Farm A has 21%, and, which is greater than Farm be at 14%. Likewise for medium, farm A at 59% is greater than 50%. Right, so yes, looking at large oysters, farm A has 21%, which is greater than farm B. Likewise for medium oysters, maybe, farm A at 59% is greater than 50%. Again, it's very interesting. It says rounding percentage to the nearest whole number, which I've already done. So again, when it says explain your conclusion by comparing the values of two appropriate percentages, I don't know what it means. We'll just choose those two, or basically choose those two. If I've overdone it, well, theoretically, VCAA won't mark it wrong unless I go wrong, right? So if there's more information than I need, so long as it's correct, I think VCAA are okay with that type of thing, but it's an interesting question. All right, question number 3. The scatter plot below plots the average monthly ice cream consumption in litres per person against average monthly temperature in degrees C. The data for the graph was recorded in the northern hemisphere. Okay, random. When a least squares line is fitted to the scatter plot, the equation is found to be that. The coefficient determination is that. Draw the least squares line on the scatter plot below. Again, this is such a common question now, and I know so many people still have difficulties with it. They've given you an equation. So you've got to choose your value of temperature. And where do you get the temperatures from? You get it from your x-axis. So in this situation, I'm going to choose the smallest value they give me as -10, and the highest value they give me is 25. And I'm going to substitute it into here and work it out. So if I look at this now, I have, what's my equation? 0.1404 plus 0.24, and I'm going to multiply that by the temperature of, and I'm going to put this in brackets, -10. Yeah, hit enter, and I get what I get, -2.2596. That doesn't seem to be right. Nope, because my equation's wrong. Where's all my zeros gone? So 0.0024. There we go, 0.1164. So I've gotten so one of my coordinate points, again, with my highlighter, would you stop doing this? Oh. So one of my coordinate points is -10, 0.12, and the other one I'm going to put in is 25. So what I'm going to do now is change that equation there, and change that minus to 25, and I get 0.20. Right, nice values to choose. I think so here. So -10 goes to 0.12, so I'm going to put a cross there. 25 is at 0.2, so 25 is here. And then using a ruler with a perfectly straight line, and there you go, my iPad will do that. There we go, that's my equation of least squares line. That's on every single year pretty much now. Determine the value of the correlation coefficient R and round your answer to 3 decimal places. Right, well, they've told me the coefficient of determination. I know that that's my value of R squared. So if I square root my value of 0.7212, then I should be able to get that. So here we go, square root of 0.7212. Now, normally we would have to check, because normally they end up having your graph going this way down, but I think they've been quite nice to you here with that. So we've got to round it to how many decimal places did it say? Determine the value of the correlation coefficient R through 3 decimal places, 0.849. So I'm going to go with 0.84 and 9. Describe the association between average monthly ice cream consumption and average monthly temperature in terms of strength, direction, and form. That's unique. I've never seen that before. So form is linear. Direction is positive. Strength, that's where we've got to get the value of 0.849. So I'm just going to pause this video and get that value up. Okay, and reading off the Cambridge textbook that I've got in front of me now, between 0.75 and 1 is a strong positive association. So 0.849, let me just check that. Yep, is definitely in there. So I'm going to put the word strong, positive, and linear. Ooh, thank you very much. Right, let's keep going. There's more to this question. Sheesh. Referring to the equation of the least squares line, interpret the value of the intercept in terms of the variables consumption and temperature. Oh, the intercept. Right, okay. Because it's the intercept, you have to start with, and it's a very specific question, so I always start with on average, comma, for a temperature. Is that what we wanted? Yeah. Of 0 degrees C we would expect or get a consumption of 0.1404, 0.1404. What was the units? Please put the units in. Liters per person. Liters per person. All right. So on average, comma, for a temperature of 0 degrees, we would expect a consumption of 0.1404. Yep, 0.1404 liters per whatever. And we could sort of check that, because if you go up from 0, yeah, because again, remember, the intercept of a graph is where it crosses at 0, and they try and trick you with this type of thing over and over and over again. Use the equation of squeeze those line to predict the average monthly ice cream consumption of liters per person when the monthly average temperature is -6 degrees. So what we would say, equation is to predict the average consumption. Okay, consumption is equal to 0.1404 plus 0.0024 times the temperature of -6. Now, I've already got my calculator open, so is it going to let me do this? Yep, let's just go back up here. And I copy that one down and get rid of -10 and make it -6. So it is equal to 0.126 liters per person. And again, I'm just going to check that. Yep. So 0.1404 plus 0.0024 times -6. Write down whether this prediction is an interpolation or an extrapolation. Well, what have we got here? -6. Well, my lowest data item here is actually this one here. All right. And so -6 would be here. It's outside the data they've given me. So that would be extrapolation. Let's see if I can move this up. So I'm going to say that's extrapolation. My apologies for my handwriting, guys. But I just want to make sure that this is correct. Temperature of -6. I just want to make sure that it said -6. Yep, temperature of -6. So 0.1404 plus 0.0024 times -6. Yep, there we go. What do we got now? Oh, time series. The time series plot below shows the average monthly ice cream consumptions recorded over 3 years, from January 2010 to December 2012. The data for the graph was recorded in the Northern Hemisphere. In this graph, month number 1 is January 2010, and month number 2 is February 2010, and so on. Identify a feature of this plot that is consistent with this time series having a seasonal component. All right, so basically, there's an interesting one. Yeah, seasonal component. The graph repeats every, the graph seems to have the same form. Every 12 months is going up, down, and then up, down, and then effectively up. Yeah, so identify a feature that is consistent with the time series having a seasonal component. Seasonal has to be, it repeats, right? The peaks and troughs. So the peaks and troughs and rises and falls appear consistent every 12 months, comma, hence making it seasonal. Now, I know before you go there, many of you are now going to go, hey, I wrote this. Is this okay? And I wrote this. Is this? I don't know. I don't work for VCAA. I am so sorry. Yes. VCAA will work out what they will and won't accept. As far as I'm concerned, I've talked about peaks and troughs and rises and falls appear consistent every 12 months, hence making it seasonal. All right. So again, something along those lines. There will be a number of answers that I'm sure they will accept. Now, if you haven't already done so, can you subscribe to my YouTube channel, please? Yeah, why? Because it means the world to me. So very few people watch this stuff. Yeah, and I bust my butt trying to get my name out there so that people can go, oh, actually, he's pretty good and engaging and he can do this. But sheesh, it's just so hard. It is so hard. So if you can subscribe, it just lets me know you've watched. If you want to turn off the turn off the notifications, but yeah, please subscribe. I honestly, I get ridiculously happy. The long-term seasonal index for April is 1.05. Determine the deseasonalized value for average monthly ice cream consumption in April 2010. All right, so month 4. So I'm going to find month 4. Where are you, month 4? You are 1, 2, 3, 4, 5, 6. So month 4 is 1, 2, 3 is that value there. So it's 0.18. So my actual value is 0.18. The seasonalized value for average monthly ice cream consumption is... So using the formula that the deseasonalized is equal to my actual divided by my seasonal index, that's going to be 0.18 divided by, what is it, 1.05. Let's do that on my calculator, if you will, please. I don't know why it just hit 7. But what is it? 0.18 divided by 1.05 gives me 0.17 to 2 decimal places, 0.17. Determine the deseasonalized value for the average monthly ice cream consumption in April 2010. And I'm just going to do litres per person there. All right, so no 0.17. Let's keep going. Right, table 4 shows the average monthly ice cream consumption for 2011. Show that when rounded to 2 decimal places, the seasonal index for July 2011 estimated from this data is 1.10. Right, table 4 shows the average monthly ice cream consumption for 2011. Show that when rounded to 2 decimal places, the seasonal index for July 2011, yeah, estimated this is 1.10. Right, so July. Just going to color that in and let's see where we go with this question. Okay, so this is a really, really interesting question. I like this one a lot. So these are actually my data values. These are my actual data values. So we know that my July data value is given by my July. Let's try that one again, shall we? Let's say my July. Oh my goodness, my July data item is 0.183. Now, all I've got to do then is find my long-term average. How do I do that? Well, fire up my calculator. So when I now basically add together all of these values together, I get 2.004. How do you know that? Because it's on my calculator. I've just done it. So 2.004 is the sum of those. What have I got to do? I've got to work out my average month. So what did I do? I took my 2.004 and I divided it by 12. And that gave me, yes, my average month as 0.167. So I now know that my average is 0.167. And when I divide those together, I get 1.0958, which just so happened to round to 2 decimal places. So what you've got to do is actually put all of that in some sort of calculation. It's 2 marks. So I would probably be saying something along the lines of my average is equal to 0.156 plus 0.150 plus ... plus 0.134 plus 0.154, all divided by 12, which equals 0.167. And therefore, July is equal to 0.183 divided by which equals 1.10 to 2 decimal places. Something along those lines. You've got to give them something to mark. They've got to be able to allocate those 2 marks to something. All right. So you've got to help the examiners out there. They want to give you marks on the whole, he says. Right. Where are we next? There we go. That was the data done. Was it okay? I reckon so. Recursion and financial modeling. If you haven't already subscribed to my YouTube channel, he's getting very needy. Someone actually in my last video said, he's got a good idea for a new game, a drinking game. And I'm assuming he meant for Coca-Cola, that every time I plug my channel, you need to take a drink of Coca-Cola. I assume you were talking about Coca-Cola. Well, I'm sorry about that. I'm just really, really quite lonely. And anyway, if you can subscribe, it's great. Yeah. There are something like, 20,000 people doing this across this year. And if every one of those could subscribe, then YouTube would go nuts. I'd actually finally get out there. But anyway, recursion and financial modeling. Arthur borrowed $30,000 to buy a new motorcycle. Dangerous, Arthur, very dangerous. Interest on this loan is charged at the rate of 6.4% per annum, compounding quarterly. Ooh, interesting. Quarterly. Arthur will repay the loan in full with quarterly repayments over 6 years. How many repayments in total will Arthur make? So he's doing it over 6 years, and he's doing 4 payments a year, 6, 12, 18. There are going to be 24 payments. Cool. The balance of the loan in dollars after n quarters and can be modeled by the recurrence relation. Showing recursive calculations determine the balance of the loan after 2 quarters. Now, again, when it's a show that, you've got to show line by line the working out. So I'm going to say A0 is equal to 30,000. A1 is going to be 1.016 times my previous value, which is 30,000. And then I'm going to minus 1515.18. Again, put that on my calculator. Fire up my calculator if you'd be so kind. Thanks very much. 1.016. I'm going to times that by 3123. I'm going to take away from that 1515.18. Hit enter, and that's going to give me the grand total of 28964.82. And my A2 is going to be 1.016 times 28964.82 minus 1515.18. So that's 1.016. I'm going to times that by that answer. I'm going to take away 1515.18. Hit enter, and out comes that. What are we going to do? Round your answer to the nearest cent. So we can do that. So 27913.08. There we go. So this is my recursive calculations. Again, these are fairly common questions. The final repayment required will differ slightly from the earlier repayments of 151508. Determine the value of this final repayment. Okay, well, what are we going to do? We can do this over how many payments was it? 24 payments. Now I'm firing up Financial Solver. So menu, finance, Financial Solver. N we knew was 24. Interest rate was 6.4% per annum. My principal value was, what did he do? Borrowed. Yep, 30,123. Payment was minus 1515.18. Final value I'm going to find. Payments per year and compounds per year. All right, so there we go. So I'm going to hit the future value. There we go. Now, what that actually means is, because it's positive, I've overpaid, or rather, Arthur has overpaid. I don't know where I got George from. George? Who's George? So I've overpaid by 13 cents. So in which case, rather than paying 1515.18, if I take away, what does it want? Determine the value of the final repayment. Yep. If I take away what they're going to be actually 14 cents, yeah, 0.14, then I'm going to end up with 1515.18. So 1515.18 minus 0.14 gives me 1515.04. So that's actually going to be the final repayment required will differ slightly from the earlier repayments. Determine the value of the final repayment. Yeah, people will turn around and say, what if I didn't round that? Well, you need to round it to be able to get that answer. And a lot of people go, why did you use your calculator? Because I don't want to make a mistake. All right, so that was question number 5. Where are we going on to with question number 6? Oh, an amortization table. Arthur invests 600,000 in an annuity, which is a big piggy bank, that provides him with a monthly payment of $3,973. Interest is calculated monthly. That's very important to know. Thank you very much. 3 lines of the amortization table for this annuity are shown below. The interest rate for the annuity is 0.42% per month. Determine the interest rate per annum. Well, if it's 0.42% per month, and interest is charged monthly, I'm going to times that by 12, and basically that should give me 0.42, and I'm going to times that by 12, gives me 5.04%. That was a nice little question. The interest rate for the annuity is 0.42% per month. Determine the interest rate per annum. Okay. I'm really worried that I'm going to get really easy questions wrong here by oversimplifying it. Let's go. Using the values in the table, complete the next line of the amortization table. Write the answers in the spaces provided in the table below. Now, what I'm actually going to do is, because not that I don't trust VCAA, I'm actually just going to take my interest and make sure that that percentage did work out that way. So we've got 2,520 divided by 600,123. Which is basically 0.42%, which is what I think they said before. Good. So that means 0.42. That's my multiplier to get. So what I'm now going to do is, to get my interest here, I'm going to take this value here and times it by that interest rate. So there's my interest rate. I'm going to times that by 597,087.90. So 597,087.90 gives me 2507.77. All right, so there we go. There's my interest. My payment, I'm assuming, is going to be 3973.00. And so my principal reduction, if you're never really sure what that actually means, I always look at those three values and turn around and say, well, how have they got to this? Well, they must have done that one minus that one. So in which case this one minus that one will give me this one here. So what do I get? 3973. I'm going to take away 2507.77 is going to give me 1465.23. And again, I like the fact that that seems higher than the previous value. Yep, so that one seems to be higher than that one there. And then how do I do the next line here? Well, I do the balance, take away that there. So what we're now going to do is I'm going to do 597.087.90. And I'm going to subtract from that 1465.23. Hit enter, and there we go. So my next line there should be 595.622.67. Okay, 1 mark. A lot of work for 1 mark, but okay. Let Vn be the balance of Arthur's annuity in dollars after n months. Right, a recurrent relationship in the term that can be model value annuity from month to month. Okay, well, in which case V0, and you've always got to use the right letters, is 60,000, or sorry, 600,000. V of n plus 1 is equal to, now my monthly interest rate was 1, was this value here. So all I've got to do is add 1 to that, he says, highlighting that. So if I do 1 plus that value there, and again, I'm going to use my calculator to check because I hate to make a stupid mistake, 0042 times V of n minus 3973. Minus 3973. And there we go. I think that's my recurrence relationship. Part D. Cool, the question never ends. The amortization tables on page 11 show that the balance of the annuity reduces each month. If the balance of an annuity remained constant from month to month, what name would be given to this type of annuity? If the balance of the annuity remained constant, that means you're only living off the interest, it would be called a perpetuity. Perpetuity. Oh, that's how they got it in this year. There's always a perpetuity question. Question number 7. Arthur takes out a new loan of 60,000 to pay for an overseas holiday. Cool, he's bought a motorbike. He's got 600,000 to invest. I want to know, Arthur. Actually, yes. Have you subscribed to my YouTube channel? Is your name Arthur? That's fine if you haven't. Otherwise, can you subscribe, please? Thank you very much. It means the world to me. Interest on this loan compounds weekly. Ooh, they are throwing all of the ones this one time, aren't they? The balance of the loan in dollars after n weeks can be determined using the recurrence relation of that form. Okie dokie. Show that the interest rate is 7.8% per annum. To show that, you've got to do the calculations, right? So again, I know that I use the calculation r minus 1 times 100 times n, which is my compound. Now, don't write that, but in this case, my r value is the 1.0015 minus 1 times that into percentage and times my compound periods weekly. There are 52 weeks in a year. And again, I'm just going to put that in my calculator to check 1.0015 minus 1, times it by 100, and then I'm going to times that by 52, and that gives me 7.8%. So to show that, you must do it. You can't take the 7.8 and turn it back into the 1.0015. You have to go from the 1.0015 and turn it into the 7.8. And again, that's just a formula. Determine the value of D in the recurrence relation if Arthur makes interest-only repayments. Now, an interest-only repayment basically means that he's going to work out the interest on the $60,000. And we know how to do that. That's 1.0015 of that. So I'm going to do 1.0015. I'm going to multiply that by 60,123. And that's going to give me 60090. Now, basically, to get that back to the 60,000, what am I going to do? So if I take away 60,123, then I'm going to have an interest of $90. All right, so in which case D in that situation, he says, writing what doesn't look even vaguely like a D, D is equal to 90. So let me just check I've done 1.0015 times 60,000. Yep, $90. Arthur fully repays the loan in 5 years. Determine the value of D in the recurrence relation if Arthur fully repays the loan in 5 years. Can't do that in my head. And why should I? Right, so we're going to do 5 years, and he's making how many payments? Weekly payments, 52 weeks. The interest rate was 7.8%. We'd already worked that out previously. He takes out a loan of 6123. His payment, we don't know. We're going to try and find it out, but he's going to future value of 0, 52 and 52. So let's work out what his PMTs are going to be. There we go. Round your answer to the nearest cent. So $278. $278.86, I think. right? Round your answers. Determine the value of D in the recurrence relation if Arthur makes interest-only repayments. $90 makes determine the value of D 90. And I'm going to take that dollar sign off for the moment, but yeah, I don't know. That feels like I'm splitting hairs, and I don't have many hairs left. Arthur decides that the value of D will be 300 for the first year of repayments. If Arthur fully repays the loan with exactly 3 more years of repayments, what new value of D will apply for these 3 years? Okay, let's start again. All right, so he's now only going to pay 3 years. I don't know what I've done there. Let's take that off. Right, so he's going to do, if Arthur decides the value of D will be 300 for the first year of repayments. So it's 52 payments, 7.8%. Principal value was 60,000. What is he paying? $300. So minus 300, and I'm going to find out his future value. So there we go. So at the end of the first year, that is how much he has got. If Arthur fully repays the loan with exactly 3 more years of repayments, what will the new value of D be? So I'm now going to copy that up. This is like a change of conditions. I'm going to take that back there. I'm going to make that 0 because that's effectively his new loan. If you imagine he's walked into the bank and he's gone, all right, I'm going to borrow 60,000. And a year later, he walks back into the bank and he goes, do you know what? How much do I still owe you? And they say $48,651.67. And he goes, okay, then, well, I want a new loan. I'll start with that amount and I want to pay it off. So he's going to pay it off. He's going to go to 0. But I've got to make sure that I change my end because it's 3 years and 52 payments because he's doing it weekly. Yes? Candidate, the balance of the loan. Yep, D. All right, so he's making weekly payments. So what am I trying to do here? Find the value of the payment. If candidate repays the loan with the exact formula, what would the value of D be? There we go, 300. Oh, round your answer to the nearest cent. So I think it's going to be $350 and 1 cent. There we go, $350 and 1 cent. Round your answer to the nearest cent. I'm just going to check that's right. 3 times 52. Yep, 156, 7.8. That was the amount we had before. Yep, 52 payments. Right, good. It's not finished yet. We've got more. For what value of D does a recurrence relation generate a geometric sequence? Well, okay, I think that's a really interesting one. A geometric sequence can't have anything added on or taken away. So in which case the D value would have to be equal to 0, all right? Because you can't have an add-on or a takeaway for a geometric sequence. It just has to be the multiplier. Well, that's an interesting question. And there we go. That is the end of Financial Matrices. Welcome if you just joined me for Matrices. Where have you been for the others? There were some really good questions in there. Darren, very pleased to meet you. Your name? Don't tell me, I can't hear you. If you could do me a favor and subscribe, that would be great. Why? Because no one watches my videos. No one watches Maths Guru videos. Why? They're watching food videos and all sorts of other things. So if you can just subscribe, it means the absolute world to me. Yeah, a lot of people say, how can we thank you? Well, other than sort of telling everyone you know and your teachers that actually these videos and my resource actually exists, just subscribing. It really does mean very, very much to me. I'm going to turn off my calculator for a minute. It's boring me. Right, question number 8. A circus sells 3 different types of tickets. A family, adult, and children. The cost of admission in dollars for each ticket type is presented in matrix N below. The element in matrix I and J is given by Nij. Which element shows the cost of 1 child ticket? Right, so rows 3, 1. So it would be N, and then little 3 and a little 1. Okay, yeah, row 3, column 1. Yeah, probably want to make that look like a 3. So let's make it look more like a 3. N3, 1. Row 3, column 1. Yeah. A family ticket will allow admission for 2 adults and 2 children. A family ticket will allow admission for 2 adults and 2 children. Complete the matrix equation below to show that purchasing a family ticket could give families a saving of $10. 0.22 times N minus, I beg your pardon, equals 10. A family ticket will allow admission for 2 adults and 2 children. 0.22. Complete the matrix equation below to show that purchasing a family ticket could give families a saving of $10. Well, 1. I think that's going to be 100. Okay. So basically, and I'm just going to do that on my calculator. If all else fails in these exams, just fire up your calculator and see what happens. They give you the information here. So what I'm going to say is let N become equal to, no, I don't want that, thank you, become equal to, and let's do this, one of these, and I want a 1 by 3. Hit enter. So what do I want? Oh no, n shouldn't be that at all. It should become a 3 by 1. 3 by 1 is giving me 36, 15, and 8. Now, I'm going to put it in there because the chances are we're going to need it. So now I'm going to do this, and I'm going to do Shift, Enter, and Shift, Enter to save me doing all of that. So I've got 0, 2, 2 times n, and I'm going to take away from that another set of square brackets and do Shift, Enter, and Shift, Enter. And that's going to be 1, 0, 0. And we're going to times that by n, and hopefully it gives me 10, and there we go. So I'm just checking it because I was like, oh, clever question. Right, on the opening night, the circus sold 204 family tickets, 162 adult tickets, and 176 child tickets. The owners of the circus want a 3 by 1 product matrix that displays the revenue for each ticket type, family, adult, and child. This product matrix can be achieved by completing the following matrix calculation. I'll write down K in the spaces below. Well, okay. So I'm looking at the orders here. So I've got, that's my 3 by 1. So this one here is a 3 by 1. I know that my N is given as a, sorry, try that one again. Yeah, 3 by 1. So I know my N is a 3 by 1. So what have I got to multiply that 4 by? Well, that's got to be a 3. And that's got to be a 3 as well. So I've got to multiply it by a 3 by 3 to be able to get, so K's got to be a 3 by 3 matrix. So here we go. I'm going to put this one down then here. So we got adult. What do we have here? On the opening night, sold 204 family tickets. I'm going to do 204, 0, 0, and then 0, 162, 0, and 0, 0, 176. Now, if we multiply that by my n, let's just check where my n is, which is 36, 15, and 8. Let's just check what happens. I'm going to do this times this. So I'm going to do 204 family times 36 for a family. And then this times this would give me the 162 times the 15. And then this times this would give me the 176 times 8, where 8 is a child price. And there we go. So realistically, they wouldn't want the extra stuff here. I just put that in for completion. That was an interesting question. Now, moving on to question number 9. What's really frustrating is I had my computer on pause. I'd already answered 9, 10, 11 and the next question, and then realized I'd forgotten to unpause it. I was not at all unimpressed. The circus is held at 5 different locations, E, F, G, H, and I. The table below shows the total revenue for ticket sales rounded to the nearest $100 for the last 20 performances. As it turned out, that became really important. Location, E, F, G, H, and I. The ticket sale information is presented in the matrix R below. Okie dokie, there we go. Right. Complete the matrix equation below that calculates the average ticket sale price at each of the 5 locations. Well, because there are 20 locations, sorry, there are 20 performances, I need to divide each of these values by 20. That's what it's actually asking me to do, divide each of these by 20. Now, how do I do that? Well, dividing by 20 is the same as doing the fraction of 1 on 20. Now, when I do my fraction of 1 on 20, I actually get, he says, hopefully my calculator is almost there. Is my calculator there? 1 on 20, there we go, 0.05. So if I multiply that by 0.05 times R, what I end up with, now I defined my value of R there. Let's delete and then multiply the two together, and basically that's what came out. So 48000, 49525, 47005, 46040, and 45065. Yep. Okay. So again, just defining R in my calculator. That's all I did here, was define R in my calculator, hit enter, and then I did 0.05 times R, and that gave me that. So that was basically the average of all of those values. The question goes on to say the circus would like to increase its total revenue from the ticket sales from all 5 locations. The circus will use the following matrix calculations to target the next 20 performance, T times R times 1, 1, 1, 1, 1, 1, 1, 1, 1. Right, well, this one here is basically just a summing matrix. R we've already defined here, so T is what we're looking to try and do. Determine the value of T if the circus would like to increase its revenue from ticket sales by 25%. So if I want to increase by 25%, I've started with 100, I'm adding on the 25, which gives me 125% of what I'm started with. Divide that by 100, gives me a multiplier of 1.25. So T in that situation is 1.25. And I wanted to check that that was true. So I did, as you can see on my calculator there, 1.25 times R times 111, and it gave me 5890875. And you're going to say, well, okay. Now what I basically did was I just took all the values in R, I added those together. So I added all of these values together. He said doing it in pen, not highlighter. I added all of those values together and then I times them by 1.25 just to check that it gave me the right answer. And if I go back to my calculator, that's what I got. So when I added all of this row together, if I added all of that together, I got 4712700. And then when I times that by 1.25, I got the same answer. So you notice that 5890875 in that one there, exactly the same. So I'm fairly confident that's right there. Okay, we move on to the next one. The circus moves from one location to the next each month. It rotates through each of the 5 locations before starting the cycle again. And I think VCAA's got a typo in this question. I wonder if you can find out where it is. The following matrix displays the movement between the 5 locations. The circus starts in town I. Okay, so that's going to become important because we're going to start in I. What is the order in which the circus will visit the 5 towns? All right, well, basically, we look in the column, we find out where the I is going to move to, and we find a 1 there. So we now know that I moves to H. Where does it go next? Well, obviously, we now find H, and we work out where the 1 is. Well, the 1 is by the E, so H goes to E. Where does E go? We look in the column for E, and it goes to G. And where does G go? It goes to F. And where does F go? It goes to I. So there we go. Now, the interesting thing to notice about this VCAA is that there should only be a 1 in each row and each column. All right, there should only be a 1 in each row and each column. Yes? All right, let's see what happens in the next question. The circus plans to add a 6th location, J. The only change to the cycle is that the circus will be held at location J after E and before G. So after E and before G. So that's where J is going to be. So we're going to go I, H, E, J, G, F, and back to I. All right, so now all we've got to do is basically complete the 3 columns in the following matrix showing the new movement between the 6 locations. Right, so does I still go to H? It does indeed. There we go. I goes to H. And then I've got H goes to E. Does H go to E? It does. Hold on a moment. What do we notice here, VCAA? Oh dear, I seem to have a column with 2 1s in it. Methinks that might be a typo. Coming back to that at another time. So H moves to E, yes. E then goes to J. So E goes to J. So E, I'm going to put a 1 where there's a J and zeros in all of that. And then E goes to J goes to G. So that should be a 1 in there. And G goes to F. So G goes to F. And then F goes to I, which we've got there. So outside of the fact that I'm fairly sure that 1 shouldn't be there, let's go with that as the answer. All right, you're probably wondering what on earth my calculator is showing all those values for. We're coming to that now with question number 10. Within the circus, there are different types of employees: directors, managers, performers, sales staff, customers attend the circus. Communication between the 5 groups depends on whether they are customers or employees and on what type of employee they are. Matrix G below shows the communication links between the 5 groups. Right, in this, the one in row D, column M indicates that the directors can communicate directly with the managers, right? Okay. A customer wants to make a complaint to a director. So what we wanted to do is we wanted to start at a customer. And we got to end up at a director. Okay, so I'm going to turn my calculator off for a moment. Just give me a space. The customer, what is the shortest communication sequence that will successfully get this complaint to a director? So C can only go to S. The reason being is because C can only go to S. All right, so now we're going to look at S. What can S go to? S can go to M, and S can go back to C. So S can go to M. Now we're trying to find a D here, right? So we've got customer to sales, I think it is, sales staff, and sales staff to a manager. Right, where does my manager go? Well, my manager here has got a number. He can go, manager can go to director, so that's good to know. Manager can go to director. Manager can go to P, performers. Manager can go to S, sales staff, and manager can go back to customer. So basically, that's my answer there. C to S to M to D. Right, matrix H below shows the number of 2-step communication links between each group. 16 elements of the matrix are missing. Right, so 2-step communication link complete matrix H above by filling in the missing elements. So go back to my calculator. What did I do? Well, I put G into my calculator. That's what's highlighted, and basically hit enter. And I know that a two-step communication is just G squared. Now, why do they give you rows and columns in this? It's so that you can check that you've done the right thing. And if we look at my calculator, yes, I've got that bottom row is 0, 1, 0, 0, 1. And I got my first column as 1, 0, 1, 1, 0. So the chances are, I think I'm correct. So what I'm going to do now is fill in the last values. 2, 1, 2, 2, 3, 1, 2, 2, 0, 1, 1, 1, 0, 1, 2, and 1. There we go. It says my 1 mark. What information do elements G21 and H21 provide about the communication between the circus employees? Right, well, if we now look at H21, that's the second and 1, that means there's no two-step communications between the director and the manager. Yes, and yet here we've got a one-step communication. So basically, the manager can only directly communicate with the director, and there's no intermediate. So there's no one between the manager and the director who can communicate as an intermediary. Now, again, how you're going to put that is a whole new discussion. Obviously, I've already answered this question previously because I recorded it and then didn't press unpause. But the point of it is, that's what I would have said. The manager can talk to the director. There are no intermediate people who can pass messages. Again, who knows what VCAA is going to accept? Please don't ask me in the comments on VCAA or on YouTube whether your answer is correct. I have no idea, okay? It's down to VCAA to decide what they're going to do. Right, a circus requires 180 workers to put on each show. From one show to the next, workers can either continue working or they can leave the circus. Once a worker leaves the circus, they do not return. Okay, it is known that 95% of workers continue working at the circus. Right, okay. I can already see where this is going. Well, yeah, because I've done the question about 3 minutes ago. Write down matrix T, the transition matrix. So let's do this first one here. All right, it's working and stays working. Well, it said 95%. So that's going to be 0.95. We know that the columns of these things add to 1, so it gets 0.05. It says once they leave, and no one comes back. So once they leave, and that must mean that that becomes a 0 there. Write down matrix B for this recurrence relation to ensure that the circus always has 180 workers. Now, when I go back to my calculator, what I did was I put my T into my calculator. You see order there for my transition matrix, and I put in my S0. I always use my calculator to put stuff in. It makes life much easier. And then what I said was, right, well, okay, well, let's do what S0 is. So that it's my previous answer, my answer register, and I did T times S0. What did I get? Well, I got 171 and 9. That means there's 171 workers left, 9 or 171 workers will go to the next show, and then 9 will leave. Well, we need 180. So that means my B value must mean that I've got to add 9 there to get that 171 up to, and I've got to subtract the 9 there because obviously once they've left, they stay left. So I don't want a number in there. It has to go. And believe it or not, that was the end of that. Thank you. And I feel like I've recorded that before. Here we go. Networks and decision maths. Hello, welcome. If you've just joined me, please subscribe to my YouTube channel. It'd be really, really good. Lads, if you're out there and you're, because boys, trying to subscribe is like hard work. Come on, bro. I don't know what that is. I still don't know what that is. Yeah. If you can click that subscribe button, turn off notifications if you never want to hear from me before. If you hate general maths, that's fine. Please don't hate me. All right. Sounds a bit needy, but clicking that button just lets me know that you watched. Turn off notifications. Just very needy, I know. A country has 5 states, A, B, C, D, and E. A graph can be drawn with vertices to represent each of the states. Edges represent a border shared between the states. Now I'm going to delete that little 3 there because it shouldn't be there. What is the sum of the degrees of the vertices? All right, let me see what we've got here. So that's got degree 2, 1, 2, 3. Let's do 3, 1, 2, 3, 1, 2, 3, 4, and 1, 2. Some of those, well, when we go down and put them into my calculator, 2 plus 4 plus 2 plus 3 plus 3 gives me 14. And yes, I do use my calculator every single time because I don't want to make silly mistakes. Euler's formula, V plus F equals E plus 2 holds for this graph. Complete the formula by writing the appropriate numbers in the boxes below. Oh, okay, V. Vertices. A vertex is a dot. 1, 2, 3, 4, 5. I have 5 dots. Faces. How many faces does it have? Well, that's an enclosed area. Well, there's 1, 2, 3, and 4. And the nice thing is here, none of them are overlapping, so that was a nice, easy 4. What about the number of edges? How many edges are there? Well, I've got 1, 2, 3, 4, 5, 6, and 7. So, do 5 plus 4 and 7 plus 2 equal the same thing? They do indeed. Life is good. Complete the sentence by writing the appropriate word in the box provided below. Euler's formula holds for this graph because the graph is connected, and I'm going to say planar. They've not used the word planar on there. I think it's a big flashing light there just to say it's going to be planar. Right, this is where I got to last time before I realized I had not unpaused it. The diagram below shows the position of state A on a map of this country. The other 4 states are indicated on the diagram as 1, 2, 3, and 4. Use the information on the graph, in the graph on page 20, to complete the table below. Match the state, B, C, D, and E, with the corresponding state number 1, 2, 3, and 4. Oh my goodness. Right, A has 2 bordering it. So A has 2 states bordering it. Right, so A can be, so, right, let's just do, oh, here we go. This is a great question, right? So 2 states bordering it. This could be A, or it could be E. But didn't they already say we had A there? So A was already given to me. So, let's see where we go with this one. So 4 has 1, 2, 3 states bordering it. So number 4 has 3 states bordering it. Is there any state with 4 bordering it? 1, 2, 3, 4. Yes. So 2 has to be C. So C has to be 2. All right. So C has to be 2. Right. There we go. So that's C. All right. So 1, 2, 3, 4. Number 1, A and C. So A and C are joined together. This is a good question. I'm just going to rub all of this out and see where we go. All right, now going back to this, we are looking at the fact that he says A has 2 bordering it, yes? So A has 2 things bordering it. We've got this one here is a border and this one here is a border, yeah? So we've already got C as one of those borders, so I'm going to say B has to be the other one. So B, I think, has to be 3. So B has to be 3, okay. So C has 1, 2, 3, 4 things bordering it, that's fine. What have we got here? B has got 1, 2, 3 things bordering it. So B has got A, C, and number 4. So B has got A, C, and number 4. 4 must be D. Okay, and then that must be 1, 2, 3, 4. E. Where is E? E has to be 1. Right, so E has to be 1. It's got, so let me see, B, C was 2. B was 3. D was 4. And we reckon E was 1. So is E bordered by C and D? Is E bordered by C and D? It absolutely is. Now, I probably made a real meal of that. There's probably sitting there crying at the screen, but that's okay. It doesn't matter. Here we go. Question number 13. The state A has 9 landmarks, G, H, I, J, K, L, M, N, and O. The edges on the graph represent the roads between the landmarks. The numbers on each edge represent the length in kilometers along each road. 3 friends, Ellen, Reynolds, and Shyla, meet at landmark G. I'm sure they do. Here we go. Here's G. What is the minimum distance Eden could travel from G to M? The minimum distance Eden could travel from G to M. Right, Dijkstra's. Let's see whether we can give this a go with Dijkstra's. So that's going to be a 1.7. That's going to be a 1.5. And that's going to be a 1.8. So we choose, so that's a 0. Choose the smallest one of those, gives me the 1.5. And let's see where we go with that one. So 1.5 could get me back up there to 2.6, but I've already got a 1.7. 1.5 plus 0.9 gets me to here, so it gives me a 2.4 there. And I got a 1.5 plus a 1.2, which is 2.7. What's my smallest value? It's 1.7. So there we go. 1.7 plus the 1.1 gives me, nope, that's no good because 1.5 is smaller. 1.7 plus the 3.2 gives me 4 points, so that's no good. I've exhausted my H. Where's my next smallest number? 1.8. So let's go my 1.8. 1.8 plus 1.8 to L gives me 3.6, but I can get there quicker. 1.8 and 2.4. I'm just going to add that together on my calculator. 1.8 plus 2. Oh my goodness. 1.8 plus 2.4 gives me 4.2. So I can get there in 4.2. Getting closer and closer to M. How exciting is this? Right, where are we now? Smallest value would be 2.4. So there's my 2.4. So 2.4 plus 0.9, not smaller than that, 1.5. 2.4 plus 1.4 gives me 3.8. So that becomes 3.8. I'm now at my 2.7. 2.7 plus 3.2 gives me 5.9, I think. 5.9, yep. And to J, I'm not really interested in. So 3.8 plus the 2.6. So 3.8 plus 2.6 gives me 6.4. So I'm going to go in this situation with 5.9 as the minimum distance Edon could travel from G to M. Reynold would like to visit all the landmarks and return to G. Write down a route that Reynold could follow to maximize the total distance traveled. Minimize the total distance traveled. I'll be honest with you guys, I hate these questions. I literally do not know how to even approach these. So bear with me. Okay, I actually find these questions really irritating because I can't see that there is an algorithm for this question. If there is, I absolutely don't know it. So for Reynold would like to visit all the landmarks and return to G. This was my thinking. And if you've got a different way of doing it, please do let me know in the comments below because, yeah, don't like these questions at all, to be honest with you. Right, so Reynold would like to visit all the landmarks and return to G. Write down a route that takes. So what I said was, well, G to H. 1.7 is actually much quicker than trying to go sort of along here. Because if I try to go through K, that's going to be 1.6, 2.6 to get to here. But I can get to here in a lot quicker, although admittedly I could also cover K in that 2.6. So there's my question, in which is it would be quicker to go there. Anyway, so then I got to K, and I was like, okay, well, K to I is a given, because there's no point going to there and then come back again, 1.8, when I can get to I in that. And then I've got the 2.8, because that's quicker than going 3.2 and back and along. And then obviously I have J, so I had the 2.1. Then I get to here. By the time I get to here, I think it's a hop, skip, and a jump. Now, again, I haven't explained that very well, and I know that, and I'm going to spend more time on this question at a different time. But at this moment in time, I'm fairly sure that if I add all those values together, I get 16.5. So I'm going to put 16.5 at this moment in time, kilometers, and see what happens. We move on to the next one. Shyla would like to travel along all the roads. To complete this journey in the minimum distance, she will travel along 2 roads twice. Shyla will leave from landmark G, but end at a different landmark. Okay, so this is annoying, and I'm going to leave this on here for a moment. I don't think there's an algorithm to this in any way, shape, or form. I think this is just a time waster question, which makes me wonder why VCAA put it on. But long story short, Sylvia would like to travel along all the roads. To complete this journey in the minimum distance, she will travel along 2 roads twice. Shyla will leave from landmark G, but end at a different landmark. Okay, complete the following by filling in the boxes provided. The 2 roads that will travel along twice are the roads between. All right, so let's see. We're going to start at G. Let's go down to here, along to here, up to here, down to here. Right, so I'm going to go back along NL. So there's my NL. I'm going to go up here, along here, around there, down here, along there, down here, 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 back down there, back up there. So I've got to go MJ, along there, and I'll finish at H. I've done it, believe it or not, I've done it a few times, and as far as I'm concerned, it doesn't matter which way around you do it. I think there's a bit of a red herring in the terms of, you know, the minimum distance. I think the number of ways I do it, I always tend to go along NL. So I'm going to say NL, and what was the other one? M and J. I'm so sorry to those people out there who have spent hours and hours and hours working. I mean, obviously you didn't. If you ran out of time on that, that's just really unfair. There's not an algorithm. It's just guess and check, really, in many cases. And I will come back before the end of this video and just check that 16.5. Right, let's move on before I have some sort of coronary. Right, Right, now moving on to question 14. One of the landmarks in State A requires a renovation project. If you haven't subscribed to my YouTube channel, could you please? The project involves 12 activities A to L in the directed network shown below. In completion. The table below shows the 12 activities that need to be completed for the renovation project. It also shows the earliest start times and the duration and the immediate predecessors for the activities. Right, okay. Write down the immediate predecessors for activity I. Did that say I? It said I. Where are you? I. So here we go. Here is I. Right, what can I can only start when what has been finished. G and C. All right, so G and C. So I'm going to say C and G there. Hopefully I got that right. What is the earliest start time for activity J? Right, so I'm going to zoom in and I'm going to draw all those annoying boxes. So when we go that way, we want the largest, and when we go that way, we want the smallest. Right, see what happens. So that's going to be 0 and 0. Right, A takes 6, so C is going to start at 6. D is going to start at 4, and E is going to start at 4. Right, 4 plus 5 gives me 9, so G can start at 9. H can start at 9. Okay, let's see what we've got here. 4 plus 10 is 14. 9 plus 7 is 16, so I'm going to go with 16. So J is going to start at 16. Right, what have we got now? So we've got 6 plus 7 is 12, 13. So F is going to start at 13. That could also start at 13. All right, so let me see which is the biggest number to get to. G starts at 9 plus 3, 9, 10, 11, 12. 13 is going to be the start. So that's going to be a 13 there. All right, 13 plus 4 gives me 17. 13 plus 6 gives me 19. So I'm going to say that K is going to start at 19. I've got everything so far. 16 and 6 gives me 22. 19 and 4 gives me 23. L plus 1 gives me 24. So draw my one box at 24. All right, what was the question actually asking? Let's zoom back out for a moment. What is the early start time in days for activity J? What did I have? 16. So I'm going to go with 16 for that one there. Right, how many activities have a float time of 0? Let's see what we now do. So we've got to backtrack. So I'm going to zoom in, doing a different color. So it's going to be 24. 24 minus 1 is 23. Okay. 23 minus 4 gives me the 19. 23 minus 6 gives me 17. I think 17. Yep. All right. So what do we got here? 19 there. 19 minus the 4 gives me 19 minus 4 gives me 15. 19 minus 6 gives me 13. Happy that that one is there at this moment in time. All right. Where have we here? 13. So I've got a 13 here and I've got a 15 here. So I'm going to choose the smallest. It's going to give me 13. 13 minus 7 gives me 6. He says doing that, and that was annoying. That's going to give me 6 there. 6 minus 6 gives me 0 there. So that's one there. Right, what do we have here? 13. So 13 minus 3 gives me 10. That's a 10. What have we got here? 17 minus a 7 gives me a 10 there as well. 17 minus 7. And 17 minus 17 minus the 7 gives me 10. Yep. 17 minus the 10 gives me 7. All right, got a choice coming into this one here. So 10 and 10 with the choices coming in. So we'll choose 10. 10 minus 5 is 5. Going to choose the smallest, which is 10. All right, got a choice coming here, which is 5 and 7. Choose the smallest, which is 5, which gives me 1. So with any luck, that is my tracking done. So I'm now going to highlight the ones with the 0 float time. 1, 2, 3, 4, 5. Now we don't count the finish. There we go. So hopefully my critical path is A to C to I to K to L. All right. So with any luck, if we've got a crashing question coming up, that will be later. So 1, 2, 3, 4, 5. So I'm going to write 5 for that one. Okay, here we are. We're at the crashing question. Didn't we just know this was going to come? Right, the managers of the project have a maximum budget of $15,000. Okie dokie. To reduce the time for several activities. To produce the maximum reduction in the project's overall completion time. Complete the table below showing the reduction in individual activity completion times that would achieve the earliest completion time within the $15,000 budget. Right, okay, so the first thing I'm going to do is I'm going to go back here and I'm going to effectively go through all of my paths through my network. So those of you who've watched my videos will know that basically I tend to list all of the things. So what I'm going to do is, if it's okay with you, I'm just going to copy a piece of paper that I have earlier created. All right, now, so what I ended up with was my paths were A, C, F, K, L, A, C, I, K, L, B, D, G, I, K, L, B, D, H, J, L, and B, E, J, and L. So those were my paths. Then what I would normally do is I'd write down all of the numbers on them, which would be 6, 7, 4, 4, 1, 6, 7. These are just the duration times, okay? 4, 1, 4, 5, 3, 6, 4, 1, 4, 5, 7, 6, 1, 4, 10, 6, and 1. Whew, that took some time. Now, the reason being is because I want to see how long each of those paths take. So I normally draw a straight line here. Thank you very much. And that gave me 22, 24, 23, 23, and 21. Okie dokie. Are we ready? Now, what I also need to know is the ones that I can actually crash. So from the question, if you remember, and again, I'm not going to keep scrolling up and down. I've sort of got it here. A can be crashed. B can be crashed. F, K, I and K, I and K, and H. So those are the ones that can be crashed. We've got 15,000 budget in which to do it. And what I'm probably going to do is scroll down and see if I can actually do the value. So A is 1,500, B is 2,000. All right, so we got A is 15. He says, come on, rub that out. 1,500. B, I'm sorry, we said was what? 2,000. A, B, F, I. So F was 2,500. And it was H, and then I, and then K, I remember, was 3,000. What have we got here? 3,000, and then 1,000, and 1,500. And basically, I can't crash any more than of those than 2. All right. Oh, you can't fit this on the screen, so there we go. We'll give it our best shot there. Let's maybe move this up so I've got a bit of room for you guys to see. Okay. So what I did then was go, well, okay, so what's the biggest one I've got first? So the biggest one I got first is this one here, which is 24. So I'm going to choose the cheapest thing that I possibly can there. And as it turned out, it was going to be A. Okay, because the cheapest thing there was A or H or I. Well, I've only got an I in here. I've got an A in both of those, so I just reduced it. Okay, so I went, well, okay, let's just reduce by A. So I'm going to put an A on there, and then that made that 21, 23, 23, 23, and 21. So we'll write down the length of the times, cross those through just so I don't get confused. That was A. I've now spent one of those. What was the next one I wanted to do? Well, now I've got 3 23s. So I've got 3 23s there. What can I bring down? What's cheap now? I. Well, I basically went, okay, let's bring down my I's. For the moment, that will get 2 of my 23s. Is there anything else that I can bring down that's like 1,500? Well, I don't know. So I brought my I down next. So bringing that down gave me 21. That stayed at 21. That brought that down to 22. That came down to 22. That stayed at 23, and that became 21 as well. All right, so I've got one I. What have I got next? I've got a 23 here, so I'm going to bring down a H. All right, so I'm going to bring down a H to bring down that 23. So that stays as 21, 22, 22, 22, and 21. Okay, so there's my H. And I'll put 1 down there. And basically, I just kept working through over and over and over to get. Obviously, I've got to keep an eye on my costs, but we'll see where we go with this. Right, what did I do next? Well, I'm back to this. 3 of these are the same. So I'm bring down an I again. I suppose I can bring down an I again. So there's another I. So that's going to be 21, 21, 21, 22, 21. Okay, so 21, 21, 21, 22, 21. And then I can bring down another H. So I got A, and I got another I, and I got another H. Now, basically, I've exhausted my I's and H's now. So it becomes 21, 21, 21, 21, and 21. Ka-ching. Yay! What else can I bring down? Well, they're all the same, so I can probably bring down an A. Let's bring down another A. All right, so I bring down an A. That makes that 20, 20, 21, 21, and 21. So there's an A, and now let's bring down a B, because there's a B showing all those, and B is relatively cheap. So let's bring down another B, so that's 90. Oh, sorry, nope, don't do that. 20, 20, 20, 20, and 20. All right, so there's a B. All right, what else can I do? Well, B's relatively cheap, so I can do another B. There's 2,000. So I brought down another B, which gave me 20, 20, 19, 19, and 19. And then, well, basically then I added all of those up, and that gave me 3,000 for the A's, 4,000 for that, 2,000, 3,000. So 3, 6, 10, 11, 12. So that was 12,000. Now I had a 15,000 budget. Could I bring anything else down, do you think? Absolutely. So I had one more that I could bring down, and it just so happened that to do that, I had a K I could bring down. So by bringing the K down, that gave me 19, 19, 18, 19, and 19, which gave me my K value there. And so I reckon this now becomes 2. What did I say there? 2, 2, 0, 2, 2, and 1. Whew. And believe it or not, guys, that's the end of that question. How exciting is this? Right, let me go bigger. Well, thank you very much for watching. My name is Darren from Maths Guru. Hopefully this has been helpful. If it has, do me a favor and spread the word and let everyone out there know that this video is there for them. That would be greatly appreciated. Otherwise, well, you know, you're done. You're finished. Thank you very much for any support you've given me. I really want other people to learn from my videos, and hopefully teachers out there will finally start to realize this stuff is there. But for now, I'm going to say goodbye. Subscribe to my YouTube channel if you can. It just shows me you watch this video. Otherwise, you take care and please stay safe and good luck in whatever you do from now on. Take care. Bye-bye.